Alright, so this video sums up the previous 5 videos about polynomials, and we're going to do an example and combine everything we know so far. So we've got f of x is x to the fourth plus 4x cubed plus 4x squared plus 64x minus 192. And so that's a polynomial function. The degree is 4, okay, because it's the biggest exponent out here. It's written in standard form, not in factored form. The domain would be all real numbers. All right, and we could talk about what that looked like. We could certainly use a graphing utility to graph it. This is a common problem where we will find all of the roots given one of them is, and I left it blank, okay? So depending on what hint I give here, you can get further along with it. Now, if I gave you a hint that this was, let's say I said it was x, let's say, I don't know, one of the roots was 7, all right? You would change that root of 7 into x minus 7, which would be a factor. And then you would have x minus 7 times something to give you this, right? So let's think about that. X minus 7 times what would give you this? Well, certainly you'd have to get x to the fourth. So you would be multiplying x minus 7 times a cubic, a third degree polynomial, something with an exponent of 3. And then you'd have to keep going from there, but I haven't taught you how to deconstruct degree 3 polynomials, at least this year, because we've had limited tools. So the hint I'm going to give you is actually going to help you out, although it looks more complicated. The hint I'm going to give you is that one of the roots is negative 4i. Okay? Now it's a complex number. It's got an imaginary component here. Negative 4i is an imaginary number, right? The thing about imaginary roots is that they come in pairs. So anytime you have an imaginary component like the I, which is the square root of negative 1, they come in pairs. So the fact that I gave you one root is negative 4i automatically means you know one of the other ones. It means that two of the roots so far we know are negative 4i and 4i. So far, that's our list. That's our list. And we're going to have, how many more do you think we're going to have? We're going to have 2 more. Now, we don't know what these other 2 are. One of them might have what's called multiplicity 2, but there's going to be 4 roots. All multiplicity 2 means if, let's say, the other root was 3, right? It might be a factor of x minus 3, and that factor is squared. That would mean it has multiplicity 2. But we're going to have 4, okay? Because the degree is 4. The fact that I gave you negative 4i means that it's going to come with a pair that's its complex conjugate. Okay, so it's always plus or minus. So negative 4i means that positive 4i is also going to be 1. And that is helpful because I can write the factors that are associated with those two. X minus 4i would be, actually I guess this would turn into x plus 4i, and this one would turn into x minus 4i. So we know this times some other factors is going to equal f of x, right? And our goal is going to be to figure out what these two are. All right. Now this can actually be multiplied out, and what we're going to do is we're going to multiply it out and divide f of x using a factor box. And what we're going to end up getting is this stuff that we will be able to factor, and I'll show you what that looks like. So we're going to start off by multiplying these together. When you multiply those together, if you can do it in your head, that's fine. But basically, I'll write a teeny tiny little factor box here. Teeny tiny one. Hopefully, you'll be able to see that. X 4i, x negative 4i. This is x squared. This is 4ix. This is negative 4ix. Negative 4 times 4 is negative 16, but I times I is negative 1. So this turns out to be positive 16, and these two terms cancel. So these multiply together to give you x squared plus 16. So x squared plus 16 times some other factors is f of x. Okay? Now, it's not surprising that it's x squared plus 16. If we thought about x squared plus 16, that's a parabola. This thing is a parabola that opens up starting at 16 on the y-axis, meaning it doesn't cross the x-axis. This part does not, right? Which is why I had imaginary roots to begin with. Okay? So, let's use our factor box like we've done before. I know that this is going to work because I was told that x squared Well, I was told that negative 4i is a root, which means x plus 4i is a factor, and since I know they come in pairs, I know that both of these are factors, which means if I multiply them together, that's going to be a factor. So I know whatever I get down here, this times something will give me what's inside. Now, let's write down what's supposed to go inside so we can keep track of this. So I'm just copying from up above. I know that I need x to the fourth. I know I need 4x cubed. I know I need 4x squared. I know I need 64x. And I know I need negative 192. I know I need all 4 of those pieces. Okay, so I don't want to forget any and leave any behind. Alright, so let's start off. I know I need x to the fourth. Okay, so this is going to have to be x squared. X squared times this would be x to the fourth. X squared times 16 is 16x squared. Okay, this is where things get messy because I've got an x squared term. I have it here and I have one inside the box already, but I've missed this 4x cubed. So I don't want to skip that. So I'm going to write 4x cubed here because I need to make sure I don't skip that 4x cubed term. All right? And I can get 4x cubed by saying this has got to be 4x. I think I've seen a lot of students get confused because they always think that you have to combine them diagonally. It doesn't really matter which order. I've actually seen students put x squared up there and 16 down here, and it doesn't make any difference. This is just to organize our work. Okay? So don't get thrown by that. 4x cubed was next. So then 4x times 16, that's going to be 64x, which, what do you know, I needed that, so we're good to go there. Alright, so let's not forget again, the 4x squared term. I had 16x squareds. I need 4x squareds, not 16 of them, so I need to get rid of some of these 16. So I'm going to do negative 12x squared, because negative 12x squared and 16x squared can be combined to give me the 4x squareds that I need. Alright. And then that means this must be negative 12. Negative 12 times x squared is this, which is what I wanted. And then negative 12 times 16, what should that equal? It should equal this, and it does if you multiply it out. You might not know that multiplication table, 16s and 12s, I don't know. But it works out perfectly. Now if it doesn't, you messed something up somewhere, because we know we started off with some fact that was given to us. Certainly you could have messed up here too. If you wrote x squared minus 16, that would have been a mistake. Alright, so we have moved further along. We've got x squared plus 16. That times x squared plus 4x minus 12 is equal to f of x. And we are trying, remember our goal is to find all the roots. So I'm going to keep breaking this down into its factored form. I'm going to keep breaking this part down. I know this factored form, and I know the roots for this part. I need to deal with this. So x squared plus 4x minus 12. We did an example kind of like this. This one you can factor. Oops, I kind of wrote that kind of weird. I need two numbers that multiply together to give me negative 12x squared, but add to 4. So let's see, 6x and negative 2x, right? 6 times negative 2 is negative 12. 6 plus negative 2 is 4. So I know I don't even need to worry about a box here. I know my factored form for this polynomial is this. My factored form is going to be x plus 6 and x minus 2. That is equal to f of x, but I am not done because these are factors, these are not roots, but my factors can give me my roots. So the roots, to summarize, are, and I'm going to list them out using set notation, and I usually try to go least to greatest. So let's see, this would cause a root of negative 6, this would cause a root of 2, and then I'll just list my imaginary roots. 4i and negative 4i. Like I said, there would be 4. Okay. Now if it turned out that I got, let's say this factored to x plus 6 times x plus 6. Let's say these were both x plus 6. That was kind of what I mentioned earlier, where you'd have a factor of, if it was x plus 6 squared, your root would be negative 2, and you'd look at your roots and you'd say, hey, there's only 3, but one of them is kind of a repeated root. It's multiplicity. We didn't spend much time on that in this class, but that's all right. So there will always be 4 if the degree is 4. If the degree is 5, there will be 5, but you could have some kind of repeated roots. All right. Here's my roots. Make sure you're distinguishing between roots and factors when you write that. And I hope that that helps.